Very good afternoon, students. Welcome to chemistry class of PUC first year. So, as you all know that this is very first class of your PUC first year. So, here we are with the very fresh chapter, very first chapter of PUC first year. That is some basic concepts of chemistry. Some basic concepts of chemistry. Now, about this you already studied very little bit in your bridge course classes. So, those who are new to the class, so we'll go from the very beginning of this chapter. Okay, so till now you all came to know that the importance of chemistry. The importance of chemistry. Now this chapter is very important as it may name as basic concept. It may name as basic concept, but this chapter is connected to each and every chapter of PUC of chemistry. That may be first year PUC or that may be second year PUC. This chapter is connected to each and every chapter. And we are going to use all the terms whichever we are going to learn here in our future chapters. So in chemistry, we are having total 30 chapters and this chapter is connected to all the 29 other chapters. Getting? So it is very important. You can say most important as well. As the days are built over for this chapter, you will come to know the importance of the chapter. And as you go on solving number of questions, as number of MCQs are increased, you will come to know the difficulty of the chapter. But it will get easy if you understand the concept thoroughly. Getting? So here the concept which you are going to learn this in this chapter is to be very important to learn, to understand the further all chapters. Or we can say in all further chapters, as we are going to use this everything, whatever we are going to learn here is to be understood very thoroughly. Clear? So we are going to start from very beginning of the chapter, and that is the definition of chemistry. What does mean of chemistry? What is actually chemistry? As all we know that chemistry is very essential for our life. In each and every moment of our life, we are dealing with the chemistry. Or we can say that in every moment of our life, we are having chemicals, we are having chemistry elements with our surroundings. So what actually that chemistry is? What actually chemistry is? Chemistry is a branch of science which deals with the chemistry. Chemistry is a branch of science which deals with, it is a branch of science which deals with composition properties and structure of matter. You will get to know that, you will get surprised that many of the MCQs are on this definition itself. In the beginning of the MCQs, in the first level of questions, you may get questions among the following which is correct. Chemistry deals with the structure, chemistry deals with the composition, chemistry deals with the reaction, chemistry deals with the interconversion, chemistry deals with only solid, chemistry deals with only liquid. So such types of option you will get. In that you need to very careful to understand that chemistry deals with the all composition, properties and structure. Composition, properties and structure of whose? It is of matter. It is of matter. Getting? So this all chemistry, whatever we're going to study is about their compositions. What does mean of composition? How does they are made? What are the elements are present? How they are combined? So these are all our composition. Getting? Which molecule is formed based on which proportion? What is the ratio of that molecule? That all will come under composition. properties, how they behave, what is their nature, whether it is solid, liquid, gas, how it is behaving with some different elements, different compounds, that is their properties. Getting? And their structure, how they made up of in their structure, what is actually their structure, whether they are aliphatic, cyclic, aromatic, many compounds are there. So depending all these, the chemistry is depending all these properties, depending all these things, the chemistry is completely depending. And these all of which of matter, it is all of our matter. What is matter now? What is matter? As all you know that matter is a substance, or it is anything which occupies space and have mass. Matter. So I'm coming to matter. Matter is anything which have mass and occupies space. Now, in your day-to-day life, we come with all the things which are present around us is a matter. For example, the pen, the electromagnetic pen which you are using here is have some mass of around 100 gram. So it have mass and it occupies certain space. So this is a matter. Anything which is around us is a matter. That may be pen, book, ball, anything. Lot of examples are there. And this matter is made up of only 118 elements. Only 118 elements, and we have billions of matters around us. And it is made up of only 118 elements. We'll come across with that, which are the elements are made up of. We'll come across within the future chapters. Getting? So it is very important to know that whatever we are surrounded is all of matter only. It is matter only. That may be anything. We may take anything. It all is our matter only. And it is very difficult to imagine our life without chemistry. The application of this chemistry is very, very large. We have very less examples as a non-matter. We have very less examples which are a non-matter. What does mean of non-matter? The substance which do not have mass, and that should not occupy the space. So can you think of that anything which is around us is do not have mass and it do not occupy any space? As soon as we think of that, we suddenly get air. Example of air. But air can occupy some space as well as it can have a mass. You might have done experiment in your lower classes that air can be filled in balloon and it can measured in terms of mass, and it occupies the space in the balloon. Getting? So air is not a non-matter. So non-matter is that it should not occupy any space. It cannot be stored, and it should not have any mass. One important example of that non-matter is, if I give example for non-matter, as I told you, all these are having very, very less examples for non-matter. And one important example for non-matter is sunlight. Sunlight cannot be stored, as well as it do not have any mass. It do not occupy any space. If it would have been stored, it would have been occupied any space, then we would have got used the sunlight in the night. But that is not possible. Of course, you may ask that solar panels uses the energy of sunlight, but it cannot store that sunlight. Similarly, sound waves. So you may get a question like, among the following which is not a matter? among the following which is not a matter. So you may get the example of sunlight, sound waves. Sound waves, waves. We can hear the sound, but we cannot see, we cannot store that waves. We cannot store the waves, sound waves. We never see waves as well, coming waves towards us. So these are the examples of non-matter. And rest all thing, whatever, there are many some more examples you can go through, but we have very few examples of non-matter. Now the rest all things whichever present around us is a matter. Of course, anything it may be, you can take example of anything. And as I told you, we are very much depending on the this matter. Each and everything which is around us is matter. For example, we have dealing with many things according to the chemistry as a matter. For example, if I take everything as a matter which comes in the chemistry, and we have many scope of this chemistry in our day-to-day life. So let me take the scope of chemistry in our day-to-day life. Let me move on to then I will again come back to our matter. Scope of chemistry. Or you can say application of chemistry. As I told you, in each and every moment of our life is dealing with chemistry. That maybe I already gave the example of that. From beginning of the morning to the end of our day, that is while sleeping as well. We'll come across, we'll dealing with the chemistry. As soon as we get up, we take a cup of tea. Tea is made up of water, sugar, milk. So water is we know very well, we use it as a H2O in a chemistry. And sugar, C6H6O6 or C6H12O6, that is glucose, sucrose, many things will come across. Even before that, before having tea, we will used to take a toothpaste along with a brush. So brush is made up of a kind of plastic. Toothpaste is also made up of some of the composition of compounds. So in each and every moment will come across our life with a chemistry. Correct? Apart from this, we have very essential application in our day-to-day life, and that is medicines. In medicine, we use them very lot. We use medicines in our day-to-day life almost in every diseases. So chemistry has given many important medicines. For example, the discovery of anesthesia. Discovery of anesthesia made surgicals very easy. Before that, it was very difficult for the surgeons. Many operations are made by giving the anesthesia. You all very well know that anesthesia is used to make unconscious to the person. Then analgesic, right here. Now, analgesics are used for the decrease the pain. It is used for decrease the pain. Whenever you feel body pain, we take a painkiller, and that is nothing but our analgesic. Then antipyretes. Antipyretes are used for the decrease the temperature. Whenever you get fever, you take some medicines, and that medicine is used to decrease the temperature of the body, which are called as antipyretes. And analgesics are used to decrease the pain of the body. So these all are given in our NCERT, and we may get question that among the following which is used for decrease the temperature, which is used for fever, which is used for decrease the body pain, which is used as a painkiller. Getting? So one of the important application of our chemistry is medicine. And recently two important medicines are found for our, which is saving many lives. That is, one is cisplatin and Taxol. Both are used for This is cancer therapy. Cancer therapy. Once this question is also asked, the cisplatin used for the disease of the very clear it is used for treatment of it is used for treatment of cancer patients. Another one is AZT. AZT. It is an important discovery of medicine. It is used for the AIDS victims. AIDS victims we are using. So previously it was known that there is no medicines for AIDS victims, but now we have given that is chemistry has given an important medicine for AIDS victims. Like that, we are having many medicines which is related to chemistry. Apart from this, in our everyday life, we want foods, fibers, that is many things we intake. So all the foods are related to chemistry, and we are using the cloths, fuels. So in our day-to-day life, it is very, very difficult to imagine without chemistry. So in each and every moment, we want the chemistry. So application of this chemistry is very, very wide. You need to learn it very well, and you need to read the applications. Clear this? So moving on to the next part, that apart from application, we move to our classification of matter. Classification of matter. Still lots of application are there, and still many things to be discovered. And it's your responsible in future to discover all other essential parts of our life. Getting? So we need to tackle with many of our things in our future, and that is be resolved by chemistry, and this all will be responsible of our coming future days. Clear? So moving on to the next part, and that is our matter. As I already discussed that matter is anything that occupies space and have mass. Have mass is called as matter. And this matter is classified as, let me take a heading, classification of matter. Classification of matter. Matter is mainly classified into two parts. One is physical matter, another one is chemical matter. Physical matter and chemical matter. Here we may come across as a physical property of matter. So we may write it as physical classification of matter and chemical classification of matter. So first one is physical classification of matter. Physical classification of matter. Physical classification of matter we are studying since, I think, of your fourth standard. So physical classification of matter consists of, first one, solid. Second one, the matter can exist in the form of liquid, and matter can exist in the form of gas. So these are the three physical states. Physical state means if existence of matter, in which phase it exists. The matter can exist in solid phase, that is solid state. It can exist in liquid phase. It can exist in gaseous phase. Apart from these two, we are having, which we are rarely used. One is plasma, and another one is BEC. BEC is known as Bose-Einstein condensation. Bose-Einstein, an Indian scientist, and Einstein, Bose-Einstein condensation give this fifth matter. What is this? We'll come across now. First, solids. Solids are those which are having definite shape, definite mass, and definite volume. Solids having definite shape, have definite shape. We can say it have definite volume and mass, definite mass. So many examples are there for solid. If I take any wood, pen, pencil, paper, in terms of chemistry, copper, silver, iron, all these are examples of solids, correct? And we must remember that the solids have definite shape and it have definite volume. Apart from this, the solids are having very small intermolecular distance, low intermolecular distance. That means the distance between two molecules of solids are very less, and then they have a large or strong intermolecular forces. That means the force between two molecules is very strong. Since they have strong intermolecular force, they are very compactly packed. Therefore, they exist with a proper shape. Due to the strong intermolecular forces, they exist with a proper shape. Therefore, they are having proper volume with them. Where when you come to liquid, they have definite volume and mass, but do not have definite shape. Do not have definite shape. As all we know that liquids can take shape of any container. If you pour in the bottle, it will take a shape of bottle. If you pour in glass, it will take shape of glass, jugs, any any shape it can acquire based on the using of containers, correct? And again, here in this case, the intermolecular forces are less as compared to solid, but intermolecular forces are more as compared to gas. Similarly, intermolecular distance is slightly more as compared to solid, but less as compared to gases. Getting? So the example of liquids are, you can write any of the liquids: water, alcohol, milk, anything you can write, oils. Getting? Now it is very important that this question may ask for 2 or 3 marks for theory. Explain the classification of matter based on its physical classification. Or you may get question like, explain physical classification of matter. Explain physical classification of matter. Whenever classification is present, you need to write the classification as well as about them. So solid, liquid, gas are the classification of our matter in terms of physical. What are solid? Their example. What is liquid? Their example. And what is gas? And their example you need to write. Getting? So therefore we are going detail here. However, you have studied in your lower classes, since 4th standard you have studied, but it is very important to know that this is not the all thing about this solid, liquid and gas. We are going to study it very thoroughly, very in very explanation, more explained. That is, we are having a complete chapter about solid in PUC second year. PUC second year, first chapter itself will called as solid state, where we study all about solids only. What type of solids are present, how they are made up of, what are the types of solids. Okay, so all this we are going to study under the name of the chapter solid state, which is very first chapter in our PUC second year. Now coming to here liquid you will study under the chapter of solution, in PUC second year, as well as you will study in physics under the name of the chapter fluids in PUC first year only. In physics we'll study about liquid under the chapter of the name fluid, and in second year in chemistry you study under the chapter of solutions. So that is all about our liquid. Here gaseous also will study in PUC first year under the name of the chapter states of matter, where that complete chapter is about gaseous only, gases. So these all consist of lot of things to be learned still about these simple matters. Clear? So coming to this gas have a definite mass, but do not have definite shape and volume. Definite shape and volume. Definite shape and volume. Coming to fifth one, that is plasma. Plasma is matter present in stars where the temperature is very very high. Temperature is very high. If the temperature is present very high, it is extremely very high temperature. In that case, whatever state will be present, that state is known as our plasma state. So stars are having very high temperature, very high temperature. If any substance is present at that temperature, then that state is called as plasma state. That is called as plasma state. Coming to BEC, that is Bose-Einstein condensation. Bose-Einstein condensation, it is having very very less temperature. It is having very very less temperature. As you see that the whatever things are present in room temperature, we call it as a solid state. Now this looks like a solid, but the temperature of that compound is very very less. For example, the example of this Bose-Einstein condensation is supercooled liquids. Supercooled liquids, these are called as the BEC stated supercooled liquids, and supercooled liquids are known as glass. Glass is the example of BEC, Bose-Einstein condensation. The glass which I'm wearing for spectacles, the glass which is used for windows, the glass which is used for vehicles. These all are the BEC matter, Bose-Einstein condensation matter, which is our fifth matter. This looks like solid. This looks like solid, but it is made up of with very very low temperature. At it is the matter is cooled at very very low temperature. It will be around minus 100 degree, more than minus 100 degree Celsius will be present. If at that state the liquid will get converted into solid, the liquid will get converted into solid. So the supercooled liquids are called as fifth matter, that is Bose-Einstein condensation. Getting over here what is going on? So this is about our physical classification of matter. Physical classification of matter, you need to write about these at least three. Okay, and then our fourth is plasma and Bose-Einstein condensation. Clear with this? Right. So moving on to the next one. Next is our chemical classification. Chemical classification of matter. Chemical classification of matter. Now it is very important. If this chapter is there for theory and this part is included in your exam, theory exam, then this question will come for 4 marks. This question will come for 4 marks, where you need to elaborate this question very detailed. You need to elaborate this question in very detail. So this is one of the important question regarding theory, and that is the classification of matter, how it is classified. Matter is classified here in terms of classification, that is chemical classification, with two important parts. Two important parts. Now, as we have studied in previous here, this physical classification of matter is of very important for solid, liquid, and gas. Where even if you don't write about plasma and BC, doesn't matter, but you need to complete explain about the solid, liquid, and gas. Then only you will get 2 or 3 marks. Getting like that in chemical properties, you need to write a chart, a classification chart, which includes some points, and then you need to elaborate each part of the chart. Each part of the chart, then only will get the full marks for full 4 marks. Along with elaboration, you need to write examples as well. You need to write example as well. You may write in the chart itself, or you can take the detailed part of that each chart, but you need to explain each part of the chart. So moving on to the our chemical classification of matter. Here first, the matter is classified into two important parts. One is pure substance and another one is This is mainly classified into pure substance, pure substance, and the another part is mixtures, mixtures, pure substance and mixture. What does mean of pure substance? What does mean of pure substance? The elements which are purely present, or we can say pure substance consists of single type of particles. It consists of single type of particles. So let me write here only. Pure substance consists of single type of particles. Single type of particles. Getting? And this is further classified as, two more classification. Again, this is further classified as, one is our substance, that is elements, and here we need to write compounds, elements and compounds. Then this compound is further classified as inorganic compounds, and organic compounds. Organic compounds. So this is the classification of pure substance. This is the classification of pure substance, where you need to remember that the classification of pure substance and mixture will not be asked. The total classification you need to write. The total classification you need to write. In that, the pure substance are the single type of particles which are present with the single type of particles, and this is further classified into elements and compounds. Elements and compounds, where compounds are further classified into inorganic compounds and organic compounds. Let me write this completely. Inorganic compounds, that is organic compounds, inorganic compounds and organic compounds. Moving on to the other part is our mixture. Mixture is classified into two important parts. One is homogeneous mixture, homogeneous mixture and another one is heterogeneous mixture. Heterogeneous. Right? Let me write it. Heterogeneous mixture. So this is the chart. This is the chart of classification of matter. Classification of matter. So you need to write the chart first, then you need to elaborate each and every part here. Each and every part. If you write only chart, you may get 2 marks. 2 marks for the chart. But remember, this question will come for 4 marks in our theory. Clear? Right. So moving on to the next part, that is elaboration of each and every part here. Copy this quickly. All right. 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 Here, in this case, in the matter, we study about first pure substance. We'll study first pure substance, then we'll move on to the mixture. Okay. Now, first pure substance is a single type of molecule. Pure substance. I have written in chart as well, but these are single type of, it consists of single type of particles. It consists of single type of particles. What does mean of single type of particle? What does mean of single type of particles are present? Now here, it is very pure, it is present in pure form. Single type means it may consist of only one type of atoms, one type of molecules. If it one type of atom, then we'll undergo the elements. If it contains of the one type of atoms combined, then it will maybe compounds. So if a single type of a similar type of atoms or particles may be anything, it may be atoms, elements, many things are there. If those are present, then it will be a pure substance. Where under this pure substance we are having elements. We are having elements. As all we know that there are total 118 elements present in the periodic table. Okay, so element is the simplest form of pure substance. It is a simplest form of pure substance. It is simplest form of pure substance. Pure substance. What does mean of simplest form of pure substance? Is exist as only one particle. It exists as only one particle. It is not combined with any other particle. It is not combined with any other particle, and this cannot be decomposed. It is neither decomposed nor it is formed. Okay, we cannot form it. It will be present in our in earth crust. So we cannot destroy it or we cannot form it. Such a particles are known as elements. Elements. Getting? So these can neither be just a minute. Right. It is the simplest form of pure substance, and they can neither be decomposed decomposed and nor it is formed. Nor it is formed. So elements can neither be decomposed or nor it is formed in the simple substances. In simple substances, we cannot build them into simple substances. Therefore, these are called as elements. Okay. So elements are simplest form of pure substance. It is the simplest form of pure substance. Then what does mean of compounds? Compounds are, let me write here. Compounds are two or more pure substances. Two or more pure substances are combined in a definite proportion. In a definite proportion. In a definite proportion. So what does mean of definite proportion? Two or more elements are combined. The pure substance elements will be present. Those elements will combine with each other. In each other, and they should be in a proper ratio. They should be in a proper ratio. For example, here the elements may be any elements you can write. Let me write examples of elements. Any elements present in periodic table you can write. Carbon, silver, copper, all these are. Then we may write some gold, iron, all these will be etc. These are pure substances which are present in their simplest form. Where our compounds are also pure substance but combined, containing two or more than two elements, combined together in definite proportion. So for example, if I take here water ratio is, it is 1:8 by mass. It is 1:8 by mass. Or in terms of atoms, I can take 2 atoms of hydrogen and 1 atom of oxygen. 2 atoms of hydrogen, 1 atom of oxygen. But we never take a ratio of atoms. We always take ratio of by their mass. So mass of hydrogen is 1, and each hydrogen is combined with 8 mass of oxygen, but oxygen mass is 16. Since we are having 2 hydrogen, each hydrogen will get combined with a mass of 16 hydrogen oxygen. So mass of hydrogen is 1, mass of oxygen is 16, but each hydrogen is combined with that oxygen. So therefore we call it as 8 mass of oxygen. 8 mass of oxygen. So this is our definite proportion, definite ratio. So if any substance is formed by combining two or more than two elements in a definite proportion, in a definite ratio, then they are known as compounds. Then they are known as compounds. Clear? Now, the compounds are further classified into inorganic compounds and organic compounds. It is further classified into, let me take another page. Compounds. There are two types of compounds. One is inorganic compounds, and second one is organic compounds. Now, earlier in ancestor time, it was known as the inorganic compounds are those which are made up of from non-living things, which are made up of non-living things, and organic compounds are those which are made up of living things, which are made up of living things. But then there is a revolution come that the organic compounds can also be prepared from non-living things. The first compound is prepared is urea. That all we have come across in our bridge course. But what else we need to remember here? The inorganic compounds are formed by non-living things, and organic compounds which are formed by living things. And organic compounds are formed by living things. Under this organic compound, further we have studied that organic compounds are those which are purely made up of carbon atoms only, which are made up of carbon atoms, and that carbon atom is should be associated with hydrogen. Correct? So what I can write in the simple classification, the compounds synthesized from non-living things are inorganic compounds, where this we can understand that the compounds synthesized from living sources are our organic compounds. These are our organic compounds. Getting? So example, you may write anything over here. For example, I can write here calcium carbonate. These are compounds. Calcium is a inorganic compound, calcium carbonate, or we can write NaCl. It is also a compound, inorganic, Na plus Cl minus. Like many examples are there here. Many examples we come across. Correct? Where here in organic compounds are carbohydrates, lipids, fats, oils, carbohydrates, etc. So this is our classification of pure substance. Then moving on to our mixture. Mixtures are those. Now it is very clear that what does mean of mixture. If a compound contains two or more than two of different compound. Here we are having similar types. Getting? Now moving on to the next one. So mixtures. There are two types of mixture. One is homogeneous mixture, another one is heterogeneous mixture. Homogeneous mixtures are those where the proportionality or the phases are same throughout the mixture. If the composition phases are same throughout the mixture, then it is known as homogeneous mixture. If it is not same throughout the mixture, then it is called as our heterogeneous mixture. So first one, let me write homogeneous mixture. Homogeneous mixture. First one is homogeneous mixture. Homogeneous, which should be throughout the mixture, it should be same. If it is uniform, throughout the mixture, a mixture is said to be homogeneous. A mixture is said to be homogeneous if its composition is uniform, or instead of you same, you can write uniform throughout the mixture. Throughout the mixture. The composition is uniform throughout the mixture, then we call it as a homogeneous mixture. So it is very clear that what does mean of heterogeneous, correct? What does mean of heterogeneous? A mixture is said to be heterogeneous if its composition is not uniform throughout the mixture. If its composition is not uniform throughout the mixture, then it is called as our heterogeneous mixture. Heterogeneous mixture. You can take any example over here for homogeneous. You can take water and salt. If salt is added to water, it will get completely dissolved, and you can take any part of that solution where it will give same composition. From in a glass, if you take water and add salt, or even you can add sugar and get dissolved, let get dissolved. Once it get dissolved, if you take any part of that solution, you take any part of that solution, it will give same taste or same composition. If it is present same composition, then of course we call it as homogeneous. Getting? So it should get completely dissolved, it should get completely mixed, then we call it as a homogeneous mixture. For example, again we can say water and alcohol, water and milk. Getting? But if I take oil and water, they do not mix, correct? So if I take water and sand, they do not get dissolved, they do not get mixed. Getting? So any example you can write over here, any example, right? So let me write this thing here. That is, first one is a mixture is said to be heterogeneous a mixture is said to be heterogeneous if its composition is not uniform throughout the mixture. Any example you can write here. Here first let me write water and solution of sugar solution. Sugar solution. Sugar plus water, salt solution. that is salt plus water, they will get completely dissolved. Water plus alcohol, but here I can write examples like sand plus water, they do not get mixed. Oil, water, getting. So these are our classification of matter based on all the things that may be our pure substance. Under that pure substance we have studied elements, under that compound. Then we have come across with our one more thing, that is mixtures. Under compound we also came to know that inorganic substance as well as organic substance. So based on this we have a wide variety of classification. Further we'll have many number of inorganic substance, many number of organic compounds we are having. So this is a very important part of this chapter, that is which will be asked usually for 4 marks. Clear? Right? So next, moving on to the next part. Physical measurements. Physical measurements. Under physical measurements, we'll come across units, which you already studied in the previous class. That is, previous class means today itself. In your physics class, the chapter is started as units and dimensions. Units and dimensions. So here we will study that one is as our units. Physical measurement is one is unit. All the units will come across, and then some measurements here, like how they have to be measured in terms of what are their SI units, that all will come across. Okay. Usually in chemistry we are having 7 basic units. We are going to have 7 basic units. Based on that 7 basic units, the further other units are derived. The further other units are derived. But these 7 units are cannot be derived from any other measurements, any other units. So which are those? Which units we are going to use? What type of a units we are having? Okay. So first let's start our first physical measurement as units. First measurement as units. There is another one physical state, that is physical measurement as numerical values, numerical measurements. How the numericals we are going to use, what type of a numericals we are going to have, that we'll study later. So first let me start with units. Units. There are 7 fundamental. There are 7 fundamental units. Fundamental units. So let me give those 7 fundamental units. What are those names, where we can use, and what is their symbols? What are those symbols? So starting here from unit name, unit's name, its abbreviation, or I can say symbol. Then here the SI unit. SI unit. Now you might have already come across with the many units, but you need to remember that these units which you are going to learn over here are very basic units, which we come across in our all the type of derived elements. I mean to say derived units. And very important, first one we are going to start here is that we all very well know that we are going to use it as for measuring the, you can say, lengths. Measuring the length. And here length is symbolized as L. Now what you have to remember, length are having many units. Lengths are having many units. It can be measured in centimeter cube. It can be measured, centimeter. it can be used in meter, it can be used in kilometer, all these things are present. But the SI unit of length is meter. It is meter, written simply as small m. Remember, we have to write it as small m. Coming to next one, second very important is mass. Mass. For mass, what you have to remember here is we write it symbol as m. Symbol as m. But unit is different. SI unit of length is small m, but symbol for mass is small m. Remember that. SI unit is different, symbol is different. That is why I am giving both symbol as well as SI unit. Getting? In many cases, you may get m is equal to something. M is equal to 5 gram, 5 kg, like that. So if small m is equal to 5 gram, 5 kg is given, it is of course mass. If anything is given 2.5 centimeter, 10 centimeter or 10 meter, let me talk about meter because it is SI unit. If it is given as 10 m, 5 m. So if it is given after the numerical value, then it is our length, that is SI unit of meter. But here the m equal to something is given, then it is our mass. Getting clear? The SI unit for mass is mass again. It can be measured in terms of gram, milligrams. But SI unit for mass is kg, kilogram, kilogram, which is abbreviated as kg, which is abbreviated as kg. Clear? Right. Next, third one is temperature. Is temperature. Again, you need to remember here the symbol temperature. Temperature will be usually symbolized as capital T. It is symbolized as capital T. Remember, somewhere if small t is given to you, if somewhere small t is instead of this capital T, if small t is given, then it is understood as time. It is used for time. Getting? So this temperature will be capital T for us, where time will be small t. Time will be small t. Let me write that also, because that is also our fundamental element only. Here time, this is t. Getting? So don't get confused between capital T and small t. Capital T is for time. Usually it will be given in the SI unit of time is Kelvin, as well as it will be given in degree Celsius. And we'll understand how to convert them, the given degree Celsius into Kelvin, Kelvin into degree Celsius. Of course, the temperature can also measured in terms of Fahrenheit. But the SI unit of temperature is Kelvin, which is abbreviated as K. Which is abbreviated as K. That should be capital K. Okay, capital K. Now, the time SI unit of time is seconds. You may get in minutes, you may get in hours, but you should remember that always time should be converted into seconds if you are taking SI unit everywhere. Getting? So this is our seconds, and the SI unit for the seconds will be abbreviated as small s. It will be abbreviated as small s. If anywhere small s is given, so of course it is our second. Next, fourth one. Fourth is fifth one, it is electric current. Electric current. Right. Electric current is used for measuring the current electricity, which is abbreviated usually as I. It is abbreviated usually as I, but SI unit for this is ampere. This is ampere, where it is abbreviated as capital A. Symbol is I, where abbreviation for ampere is capital A. Next is luminous intensity. Sixth one, it is luminous intensity. It is also abbreviated as IV, I nu. and it is measured, or SI unit is candela. Candela, and it's written as CD. CD. It is a SI unit of luminous intensity. Many times these SI units will be asked in for 1 marks in our theory as well as in MCQs. What is the SI unit of electric current? Getting? So last one, very important. It is very important for this chapter. In fact, all the other chapters of our chemistry. So that is mole. This is mole, which is written as small n. The symbol for mole is small n. And the SI unit for mole is, remember, MOL. MOL. Getting here? What we are writing? The SI unit for mole we have to written as MOL, where its name is MOLE. So most of the time, we will ask that what is the SI unit of mole? What is the SI unit of mole? We can say it is amount of molecules. Amount of molecules, which is nothing but mole. Getting? This mole SI unit is MOL. Don't write MOLE. You may lose your marks by writing MOLE, where SI unit of this mole is MOL only. And we don't have any abbreviation. Many times we use it as N only. But N will be given to equal to N is equal to this much, N is equal to that much. Getting? So these are our simple fundamental units from which other units can be derived. So the other units we'll discuss in our next class. Just learn about them. So we are going very slowly with basic things, and we'll gradually increase the speed, as well as we'll come across to our very important part of this chapter. Okay? So today we'll stop here and we'll continue in the next class. Thank you.